Freshwater lakes in Ontario's Boreal are home to many different species of freshwater fish that are ingrained in the cultural identity of countless Canadians and First Nations people. These species offer a strong connection to our landscape culturally, but are also a significant subsistence and financial means to people in this area. However, lurking under the facade of a seemingly pristine environment, these fishes are facing multiple stressors from climate change, invasive species, and increasing exposure to contaminants such as microplastics. Freshwater scientists are working diligently to protect these freshwater ecosystems and their fish inhabitants. And to do so, sometimes conservation work needs to happen in the most unlikely of places, such as in a walk-in fridge tucked away in the back corner of a university. Here in these tanks with newly hatched lake trout, we can start to understand how microplastics physically and chemically are affecting freshwater fish species through evaluating changes in their early development. By observing these changes, we can determine how microplastics are impacting populations of freshwater fish, like lake trout, through changes in recruitment, population structure, and productivity. Microplastics are small particles of plastic less than 5 millimeters in size, and are a result of larger plastics breaking down in the environment. These contaminants have been found everywhere researchers look for them, including inside the stomachs and muscles of fish all over the world. Since microplastics can impede food consumption and act as vectors for the accumulation of highly toxic chemicals like PCBs, mercury, and endocrine-disrupting chemicals like UV stabilizers, resource managers are highly concerned about how microplastics are affecting freshwater fish. We can then use the information gathered from this research to help guide policy decisions around plastic pollution and multiple stressors, so we can continue to see Canadian freshwater fish species and First Nation traditional resources thrive. Using this research, we can start to work towards returning these lakes to their natural, pristine state to ensure the health of these fish populations and freshwater ecosystems for future generations. Thanks to the W. Garfield Weston Foundation Fellowship for making this research possible.